Hello and welcome to Unit 6. This is called Exponential and Exponential Functions. That is going to be our title of our new unit. Here's what we're going to be going over the topic. So far we're going to go over exponential rules. Our target goal is apply exponential rules to solve problems of exponents. And what are the exponent rules and how do you use them? That's going to be the important stuff. So the two definitions that we have, the base tells us what number or variable is being multiplied. And the exponent tells us how many times the base is being multiplied. Exponents, again, mean repeated multiplication. So, review of exponents in expanded form. So what this is telling us, the base is 3. It's telling us to multiply it 2 times. 3 times 3 gives us 9. The next one that we have here is 4 raised to the 5th power. That is telling us we are multiplying 4 5 times. That means we are at 1024. Then x is being multiplied 6 times. Our value again is just x to the 6, whatever that is. So let's review this. So if we're going to expand this out, we have 3 squared times 3 to the 4th. So 3 squared means 3 times 3. Multiplied by 3 to the 4th, 1, 2, 3, 4. If we write this as the power, we notice that 3 is written 6 times. Now we're going to do the same thing for 5. We're going to write down 5 4 times. And just to show you guys a different color, red, we're going to write 5 3 times. We're going to multiply that all together. We have 7 5s. It's 5 to the 7th power. This one tells us we have 1, 2, 3, 4, 5, 6. We are 4 to the 6th power over here. And then 4, 4, 4 means we're 4 to the 3rd power over here. We add them all up, we have 4 to the 9th power over here. So the idea here is, based on the information from the table last slide, if we do am times an, this means that we are adding these two together. The one thing you need to be aware of, this only works if the bases are the same. So y to the 9th times y to the 5th, the bases are the same. We can add those two together and get y to the 14th. 2 to the 5th times 2 to the 3rd, we can add that up and get 2 to the 8th power. And then this one we can't do because 5 and 3 are not the same base. Now we're going to do the same thing over here. We're going to expand this out. So 3 to the 4th means that we are writing this out 4 times. And then the other one we are writing out 2 times. And then using division, we can cancel out 2 of the terms, and then we're left with 3 squared. Same thing over here, so we can write out 5 times 5 times 5 times 5, 7 times. And then down here, we can write out 5 times 5 times 5. Once again, do the cancellation, and then we're left with 5 to the 4th. This one tells us we have 4 to the 6th power. We're going to divide that by 4 to the 3rd power, and that ends up with 4 to the 3rd power. Again, based on the table, a to the m minus a to the nth, again, as long as it's the same one, the quotient rule is m minus n is what I'm writing here on the screen. Simplify the following. By y to the 10th divided by y to the 6th, so what I'm writing on the screen now is y10 minus 6, which is going to be y to the 4th. 2 to the 13th minus 2 to the 5th. Again, on my screen, it's just be 2, 13 minus 5, which is going to be 2 to the 8th power, as I've written on the screen. And again, 3 to the 6th divided by 2 to the 4th. Well, that's just not going to happen because the bases aren't the same. Again, all these rules need to have the same base. So, in our table, so writing down an expanded form, so this is going to be 3 times 3 times 3 times 3. Sorry, actually we're going to do this 3 to the 4th. We're going to write 3 to the 4th 5 times. And then guess what? We're going to use that rule. So we're going to add up all these 4s and get 3 to the 20th power. And then we're going to do 5 to the 7th times 5 to the 7th. Because again, exponents tell us repeated multiplication. So then we're going to add this up. We're going to go 5 to the 14th power. And then this one, we know already on the inside is 4 to the thirds, and since it's being multiplied 3 times, that's how we write that expression, and then this would give us 4 to the 9th power. This is the power of the power rule, and this tells us that as long as it's, again, same base, we can multiply the exponents together. So in this example, y to the third raised to the 5th power, we're going to write down y 3 times 5 and get y to the 15th. 2n to the 4th n cubed, so when we distribute in this 5, it goes to all 3 of them. So we're going to write down 2 to the 5th times n 4 times 5, and that should be like an m over here. An m 3 times 5, and that would give us 32 n to the 20th, m to the 15th. Now this one down here, again, we would distribute the both. And on our screen, it would be n cubed, m cubed for that one. Other rules that you need to remember: the 0th power, any base raised to the power of 0 is equal to 1. So example, 4 raised to the 0th power is 1, and a to the 6th is equal to 1. So here's our proof. I've written down on our screen, x squared is divided by x squared. So since these are the same bases, we can use the subtraction rule and get x is equal to 0. But we also know when we divide x squared, as I'm writing down here, x squared divided by x squared, we also know that's equal to 1. Thus, x squared is equal to 1. Look at that for a proof. The negative power. Any base raised to a negative power we can rewrite using its reciprocal. Basically what we're doing is, instead of it being raised to a negative power, we can switch it into a positive power, but just got to write it in the denominator. So for example, x raised to the negative 5th power, on my screen will be 1 over x to the 5th power. 3 to the negative 6th power would just be 1 over 3 raised to the negative 6. Now we're going to do a couple of complex examples. So we're going to simplify the following. So we're going to multiply actually all of this. So what will help us is, first we're going to take all the numbers. I'm going to write down 2, 9, and negative 4, for example. Those are going to be the ones that I have them in numbers. We're going to multiply all those together. Then we're going to put all the p's together, which is p to the 5th times p to the 3rd times p to the 8th. And then we're going to multiply all the q's together. So q squared times q. Then 2 times 9 times negative 4 is negative 72. P, we add all this up. So we add 5, 3, and 8 together. We get 16th power. And then we add 2 plus 1 to get 3. Simplify the following here. First thing you got to do with 3ab squared c to the 5th power raised to the 3rd, we're going to distribute that exponent in. We're also going to do the multiplication right alongside with it. So 3 times 1 is 3 for a. So all of a sudden we have 3 cubed, a to the 3rd, b to the 6th, c to the 15th power. And then we're going to do the same thing here. For 2 to a cubed b to the 8th power c. So then all of a sudden, right now, we have a squared times b to the 16th power c squared. And then we just do the same thing like we did before. So 27 is 3 cubed, and then we're going to write down all the a's together, all the b's together, and all the c's together. So this one will be 27, a to the 5th, b to the 22nd, c to the 17th. Now, this last one where we have negative 9, p to the 6th power, q to the 5th power divided by negative 3, p squared, q, all raised to the power of 2, that one can be completed a number of different ways. Since technically this is in parentheses, you can do this first if you wish, or if you also wish to distribute in the exponent to everything. So then this would just be negative 9 squared, p to the 12th, q to the 10th divided by negative 3 squared p to the 4th q squared. So then this would be 81 p to the 12th q to the 10th divided by 9 p to the 4th q squared. So then this would be 9 p to the 8th q to the 8th. If you decided to do it the other way and do the division first, where it would be 3 p to the 4th q to the 4th squared, then you find out, okay, that just goes back to this. So again, here's our concept summary. Power, product of a power we kind of talked about, and more examples here. And then there's also, this is what this would look like if you would use it as a fraction. Submit your notes in school. You're taking a picture, and then complete the Check Your Understanding worksheet. So that's your next task. If you guys don't have any questions, let me know, and I'll see you in the next video.